All right, we're doing the elimination method, and we use that usually when the equations are of this form, and so they give a little example of when you would use it. So here I am. The first thing I do with the elimination method is make sure that these things are written one on top of the other. So the top one says that x plus y is equal to 6, and the bottom says 3x minus y is equal to 10. Okay, so that side is 6 and that side is 10. Do you agree? Yeah, right, okay. So that's what I have. Now, if I'm really lucky, one of the variables, either the x or the y, is two opposites. In other words, negative y and y are opposites of each other. Do you remember that word from year 7? Like negatives of each other means opposites. One negative, one positive, yeah? Okay. So exactly, this is 1y, this is negative 1y. So they're exact opposites. And when that happens, I simply add straight down. Now, how come I can do that? Because that side's equal to that. So when I add, I'm adding the same thing to both sides. Okay, they're equal. So here I go. 1x and 3x is 4x. And y and negative y are 0. And 6 and 10 are 16. Adding to eliminate. Sometimes we eliminate the x, and sometimes we eliminate the y. Now I have that 4x is 16, and I solve that the regular old way and get x is 4. But remember, I'm finding a point, so all I've really found is this part, and now I need to find the y value. How do you find y when you know what x is? Sub it back in. So I'm going to do my substitution. Into either equation is fine. I'm going to put it in the first one because it's easier. 4 plus y equals 6, so y is 2. That's the easiest method ever, if you have opposites. The first thing I'm going to do is write them like this. I don't have opposites. I have 1 and 2 that are definitely not opposites, and negative 3 and 5. So that doesn't really help me. Any suggestions? This is where we fall into like equations are so powerful. That equal sign is the most powerful thing in mathematics because I can do whatever I want to both sides of an equation. And so what I'm going to do is I'm going to pick this equation here, and I'm going to multiply both sides by negative 2. Why? Yeah, then I'll get a negative 2y, and I'll have an opposite. Okay, so here I go. I'll just write this under here. I'll write this down. Negative 2y plus 6x. You can see where you could make a mistake there. Yeah, negative times a negative is a positive. I'm putting this all the way through. Equals negative 2. Okay, now I have the situation where I have opposites, and I can get rid of the y. I must make a point of getting rid of the x in the next one. Okay, so now once I have opposites, I should add. That's gone, and I get 11x equals 11. Now I'll sub back in. Oops, sorry about that. Okay, here we go. I've got 3x plus 2y equals 6. Can you see that pencil? Barely? Nah, no, it's no good. Be brave. 3x plus 2y equals 6. And 5x plus 3y equals 11. I've got nothing remotely like it opposite, do I? I can't really even multiply anything easily to get opposites. Like last time I could multiply by -2 and I could make an opposite. So this time I'm going to have to multiply twice. All right, so I'm going to have to multiply, oh, what? What could you do? Okay, so we decided that we would multiply this one by -5 all the way, and this one by 3 all the way. Okay, so we've done our multiplication, and now we're going to add straight down and get -1y equals 3. So y is -3. So this time I have this part of the point, and I need to figure out the x. Now, I generally go back all the way up to the original and try to figure out one of these two. It really doesn't matter which one you pick. They're both going to be the same. 3x plus 2 times -3 equals 6. So I substituted this one into the first equation, and I get 3x minus 6 equals 6, or 3x equals 12, or x equals 4.